Asseyez-vous, ça va démarrer. It's gonna kick off very soon. Don't worry, beer and food are going to be around for the whole evening. Vous inquiétez pas, la bouffe, elle reste là. Donc, tout va bien. Okay, let's get started. Hello, everybody. Welcome to this quarterly session of Kubernetes Cloud Native Meetup in Montreal. Ah oui, ça démarre. Let's go. Venez tous. Super. Okay. In case you need to connect to the Wi-Fi, then this is the password. All right. Let's start quickly introducing ourselves, who we are, actually, the organizers. There's Archie, that you should all know. Vous connaissez tous Archie, il est là-bas. Et moi aussi, de temps en temps, j'aide un peu. As well as Frédéric and Alex, who, unfortunately, couldn't make it tonight. Ils n'ont pas pu venir ce soir. Oh. Donc, l'agenda. Ce soir, we are going to talk a little bit about the CNCF news, les actualités de la CNCF. Bien entendu, vous êtes venus pour écouter les deux présentations. You're going to see the two talks tonight. There will be 4 talks. All right, so yeah, 2, all right, yeah. Okay. So 4 talks tonight, and in the middle of the 4 talks, you'll be able to network, have some food and drinks. Vous pourrez aussi boire et manger pendant une petite pause. And then please don't forget to give us your feedback. There's an event survey. We will share the link, and then you'll be able to tell us how we're doing and what kind of presentation you would like to see next. Okay, we would like to welcome our speakers for tonight. So yes, 4 talks, so 4 presenters. Saeedeh, I think I saw you. Yeah, she'll be coming up. David, there you are. Marat, there you are. Perfect. Amirreza, there you are. Super. Welcome. Thank you very much for being here with us tonight. In case actually you want also to present something, si vous avez un sujet qui vous intéresse, vous pouvez présenter en français ou en anglais. And the best way to keep in touch with us is using this link. And with this link, I believe there's a link to submit a talk. So yeah, this is perfect. So just make sure.
Update, we have a nice portal for submitting talks on Sessionize. So it's much easier now. And
what was the previous solution?
Sessionize?
No, before that.
Before it was paper call.
Yeah, it was paper call, yeah.
Not from this. That was...
Yeah, Sessionize is pretty nice because if you already submitted to other events, usually with Sessionize, you can reuse and repeat your presentations across conferences. Okay, super. And of course, well, actually not of course, but this session tonight is recorded, so you'll be able to check it out on YouTube after this evening. We would like also to give special thanks to our sponsors. Thank you to Sysdig, Grafana Labs, ChainGuard, and Arctic. Thanks to them, we are able to give you food and drinks. So thank you very much to our sponsors. Also, we would like to address special thanks as well to Lightspeed for hosting this event tonight in their beautiful office. So that's very nice of you. Superb. Let's move on to CNCF updates.
Yeah, no, I want to say thank you to Lightspeed. They told me that they want to be exclusively hosting our events at Lightspeed. So that means a lot. Thanks for commitment to Cloud Native community. We love to be here, and like people, I think, really enjoy this space. Any word you want to share from the Lightspeed? All good. See, such a nice people. So yeah, a couple of updates, I guess, very quickly. For those who is going to London, anybody here going to London? I was planning to go, but the ticket's quite expensive to fly, and but if you're going, there's going to be the schedule is up already, and there's going to be so many cool events at the KubeCon. So I'm so jealous for people who is going, but I will be at another event speaking in parallel. So it's pretty much impossible for me to be in two places. So very sad, and I'm surprised nobody's going as well because it's in London. Yeah, I'm gonna die. There's no more battery. I think we're gonna run out of the battery in a second. Let me check. All right. So this one is very strange slide, but like basically it shows the top projects last year in contribution, and Kubernetes and CNCF and OpenTelemetry is the top contributing projects at the moment. And Envoy, Cilium, Backstage, KubeVirt, Argo. So those kind of shows the project where like more maintainers, more velocity at the moment. I don't know if you agree with this, but I really see like people using Argo, Envoy, Cilium a lot, OpenTelemetry, and obviously everybody's using Kubernetes. Backstage is also like there, so it looks like there's a lot of work happening on the Backstage side. I don't know, the volume of the code maybe is big there as well. So this is how it's going. There's a couple of projects get incubated. So Kubescape, I don't know if you're using Kubescape. It's kind of Kubernetes security scanner. We didn't have anything like this for a while. There's obviously vendors that are trying to sell, but this one is like open source. They have, I think, product as well on top of that, but you can do scanning and different vulnerability stuff. So it's pretty interesting. KubeFS, I don't know if anybody's using kind of object storage on Kubernetes. Graduated, seems like a lot of users as well. There's a few projects actually been announced recently. This is coming from Google, and it's not coming as a product or anything. It's just one of our software support engineers released the project open source Kubernetes History Inspector. It basically helps you to troubleshoot issues that happened in the past, and it basically helps you to visualize logs and troubleshoot issues. Just it was a very important, popular inside of the Google, and the person who created this project, he decided to open source this. There's no plans to make out of this any special project, but if you are day-to-day Kubernetes cluster troubleshooter, this could be a helpful tool. And just deploy a Docker image. It's going to connect to your logging backends, and you can get some visualization and troubleshooting. I know that for a fact right now it's only working with cloud logging, which is Google one, but they are trying to extend. So if you're using another logging solution, you can potentially help to contribute. This interesting update as well. I don't know if any crossplane users here. Just raise hands, come on. There's not many. Although like the project is kind of becoming super popular in terms of like people like had a lot of expectation from crossplane. It didn't take off. And I think the reason is that because it was kind of complex, and it was like the resources of the cloud providers were missing or not accurate. It was like they're kind of falling behind. The recent solution that crossplane did was actually kind of makes sense. They basically, what they do, they create Kubernetes resource models, so cloud resource models based on the Terraform. So if, let's say, Azure or Amazon has their own Terraform modules, providers, they would basically take those and create cross-plane resources. But the problem usually, if there's something is not in Terraform, then you kind of have this problem that those things not going into the cross-plane resources. And so cloud providers like Amazon, Google, and Azure, they have actually their own projects that is similar to cross-plane, KCC, ACK, and ASO. And so they are like building these resources, let's say S3 or GKE. So they are actually maintaining this right now themselves, and they're building it from the SDK. So there's no Terraform involved. And so there's investment going in this space. Obviously, cloud providers, they don't want to make money out of this. They just want people to use cloud. And there's a lot of demand from platform builders who is trying to build platforms. They want to use Kubernetes resource model because they want to like unify application deployment and resource deployment. And so like the reason we're doing it because we're hearing from customers, they're saying crossplane is not always working for us. And we want that cloud providers maintain this. And so like everybody's doing this like KCC, ACK, and ASO. The problem is if you're running multi-cloud, let's say you're running Amazon and you're running Google at the same time, you cannot do this because the tool is only supported by one cloud provider. And so there's like a fragmentation in the space, I would say. And what happened basically, first time in my history, those three cloud providers talked to each other and they said, let's work on something that we can unify the experience. And they call this Kube Resource Orchestrator, KRO. And so the goal of this is going to be like more unified experience. And it basically what's supposed to do is supposed to kind of create, if you want to create modules for your resources, so this is going to be that piece. It's going to be kind of a Terraform module piece. Some people using Helm for that, but you can use KRO for that. The project is launched like a month ago, 2 months ago, so I cannot tell you this is production ready, but like just the fact that cloud providers talking to each other and they're trying to create an alternative to Crossplane, it could be a healthy competition. Maybe Crossplane will get better eventually. So like you can try, but like I think if you're already using KCC or ACK or NASO, and today we have a talk from Saeedeh, he's been talking how they're using ACK for their platform. You can start thinking about looking at KRO because KCC and ACK and NASO, they're kind of missing those high-level abstractions for platform builders. And so we're hoping that this project will be getting some traction. Maybe eventually CNCF, I don't know, like, but right now it's just OSS project. But like, I'm just hoping that there's no goal for making money out of this because it's a cloud provider. So my battery died, so like, no more slides. I think we want to invite our first speaker. Thank you. If you have questions about KRO, or I'm here, happy to answer. That was good timing. So his talk is going to be between you and Pizza, so.
Okay. All right. Okay, things work. Okay. All right. Well, hello. Hello. This is a bit weird. Okay. What? Okay. Oh my God. Where's the Zoom? It is. Oh yeah, it's already. Hello? Okay, great. You can get started. Hello, everyone. Thanks for the organizers for this event. Thanks for Lightspeed for hosting our talk. So without further ado, welcome to my talk. It's called Yoke, Kubernetes Package Management for Those Who Love to Code. Infrastructure as code, but actually. So as we kick this off, I'm sure you're wondering, who's this guy on stage? Who am I? My name is David Desmarais-Michaud, and I've been working in the software industry for almost 10 years, since 2016. For the majority of my career, I was a back-end software engineer focused on building distributed microservices. Later, I was employed by CircleCI. There's some CircleCI folk out here tonight. And I was working on CI/CD systems. And then finally, in 2023, I became a senior platform engineer, building automations from CI to CD and cloud provisioning. But this experience really, it really is important because it informs the way that I see the state and tools of the platform engineering today. And my time in software has been just long enough to discern trends in the tools that we use to develop software. When I started, I was doing vanilla JavaScript and MongoDB microservices with Express.js a la Netflix. And there was so much code and test code and runtime type guards that was needed to make input and output contracts work. And refactoring was super hard. And you need a really holistic point of view of the whole code base. That we know that what happened to JavaScript, it got pretty much unilaterally replaced by TypeScript. A little bit later, I was working on a Go team, trying to work on this Ruby monolith. And eventually, we tried to get in Sorbet to get a static type checking system. And so we kind of see this trend. And the longer I've been in the industry, in the software development field, the more we see like modern languages like Go, Zig, and Rust take the mind share. And so what's changed? Perhaps our tools are getting better. Maybe our compilers are faster, like with Go. Maybe they have better memory safety, like with Rust. But I think the more important point is that we want better tools. We want a better development experience. We want IntelliSense. We want type inspection. We want documentation. We want our software to be reliable. And I think that we want that in our infrastructure as well. And so for me, transitioning from backend to platform, that transition was difficult emotionally. Backend development felt really safe and organized, kind of like this. It was, easy peasy. You receive a request, you parse it, you validate it, you do some business logic, and you return a response. And maybe there's just some system designs in there as well, but it's okay. And the tools that we have are these great typed clients. Think Open API generation or gRPC, or at the worst case, a handwritten HTTP client. But then you arrive in the world of DevOps and platform engineering, and it feels kind of like this, right? Where you look cool, and people think that what you're doing is very arcane. But what we're doing is we're cobbling together YAML and Bash, and then we want to achieve reuse, and so we template that. So we have YAML and Bash and YAML and templated YAML and templated Bash and YAML, and it's enough to make your head spin. So here's a word I like. It's the definition of the word yeet from the Gen Z speak. And the definition is to throw, especially with force and without regard for the thing being thrown. And to some extent, I think that's how we work in DevOps and platform engineering. We yeet walls of unchecked and untyped text at our infrastructure, and we hope for the best. Often we don't know if something worked until it's in production, and if it did, good, and if it didn't, okay. But I think we can do better. So what is infrastructure as code? Traditionally, infrastructure as code was never really about writing code. It's kind of about treating infrastructure as if it were code. It's about moving the ball from that hackerman space to office space. And it's about moving away from ClickOps and SSHing into remote servers to change configuration files. So in that way, infrastructure as code is a bit of a misnomer. It's not really as code. It might accurately be as commits, still IAC. And it's what we have come to know as GitOps. And I define GitOps here as anything that you can version control that's part of your infrastructure. So your CI/CD pipelines, your cloud provisioning, and your Kubernetes cluster state and resources. But there is an alternative, right? Which is that we could have infrastructure as code, right? And this doesn't mean that we are going to throw out YAML completely and that configuration has no place or configuration languages, but we could try to build our tools not around YAML and templates. And at least that's where I hope things are going. So let's have a few quick case studies. And I didn't write these. This was by ChatGPT, so I don't know if they're accurate. But here, this is some Terraform. I just need to switch my slide over. Okay, whatever. And what we can see is that there are variables. And if I could scroll, is it scrolling? 1 second. Okay. Yeah, there we go, it's scrolling. We have variables, we have locals, we have this merge function, we have this lookup function, we have this for each clause, we have this output. Interesting. I wonder what we're trying to do here. If we look at GitHub Actions, well, this looks like normal configuration, right? But we have some inputs. We have some interpolation. We have a DAG because we're depending on another step. Here we have a matrix. This is a for loop. We have more DAG, more inputs. Here we have a conditional. Okay, I wonder what we're trying to do here. And then we have Helm, my particular nightmare. And here we have a template function, a definition of a template. and it has a range loop, an if clause, a pipe to an upper, an invocation with arguments, an else, okay, more variables. And here we have some YAML. Okay, this looks like normal YAML. And then we have another invocation of stuff. Okay, I wonder what we're trying to do here. And I think that what we're trying to do is we're trying to program, but we're not programming. We don't have a development environment. We're kind of just yeeting it as we go along. So what to do? So we have tools today. Traditionally, I would say we have, for CI pipelines, we have GitHub Actions or GitLabs or Circle CI, what have you, but it's still the same. We have Terraform for cloud provisioning, and we have Helm for Kubernetes package management. And we do have code-first approaches coming out, right? We have Dagger now for building CI pipelines. We have Pulumi for cloud provisioning, but we've never really had a good replacement over here. We have Timoni, which is based in Q. We have CDK8, which is code, but isn't really a package manager. And so this is the hole that the Yoke project is trying to fill. Voila. So we finally arrived to the subject of this talk. Thank you for bearing with me. So what is Yoke? Well, we can kind of understand it in the context of Helm. There are similarities. They're both spelled with only 4 letters. But they're both client-side package managers for deploying to Kubernetes. The difference is that packages are described as code and not YAML templates. Code is packaged as WASM executables. So that's for portability. We have a target, which is the WASM binary. And for security, we're not running arbitrary code in your systems. And so how does it work? Well, in Yoke, we have flights, and they're analogous to Helm charts. So when you're talking about a package, you'd call that a chart in Helm, and in Yoke, you would call that a flight. And the flights are programs that are compiled to WebAssembly with only the following properties. They read inputs from standard in, and they write Kubernetes resources to standard out. It's not rocket science. You provide the flight for takeoff with a release name, kind of like with Helm, Yoke takeoff, release name, and your path to your WASM file. And that's it. So we're going to go into our demo about the Yoke CLI. Disclaimer, the code is written in Go. But it doesn't have to be, right? If it compiles to WebAssembly, it'll work. If you want to write in TypeScript, use assembly script. If you want to write in Rust, write in Rust, that's fine. Okay, I'm just going to share my whole screen at this point so that we could see my terminal. Okay. All right, now we're in my terminal. I'm going to go into the examples folder. This is all findable on the Yoke CD project in the examples repository. And the first thing we're going to look at is this flight. I would like to have 2 hands, but okay. The first one we're going to look at is this program. It's the worst program you've ever seen for packaging Kubernetes. It's literally just a main. Can I have a larger font? Yeah, of course. Well, maybe we'll get there. Okay. Yeah. And so we just have a main package, imports format, has a literal deployment in YAML, and prints it. Okay, actually, you might have to hold the mic. Okay. So I'm going to pull up this. I'm going to make a vertical split, open a terminal, and we have a local Kubernetes instance running in kind, Kubernetes in Docker, and there's nothing going on in here, right? I can compile this program, go OS. This is hard to do when people are watching. Go build this out. I'm going to call this YAML.wasm, and I'm going to build out this flight, basic01 YAML. And so we should see over here that we built out the YAML.wasm file. If I run this, Yoke takeoff, I'll just give it a release name, foo, and run the example.wasm, the YAML.wasm. And I run this, we get a successful takeoff, and deployment is up. Woo, right? Voila. That's the first magic trick tonight. But this is the worst program in the world. So let's actually take advantage of the fact that we do have a coding environment, and we don't want to just yeet text around. So here is the next program. It's just a little bit more involved. It uses some standard library types, has the core Kubernetes API types that we're importing, right? This is the same types that the Kubernetes project uses. I didn't invent this. We're just leveraging the ecosystem. We have a main function which just runs. If there's an error, print it as standard error and exit with an error code. And then we just have a run, which is completely static, has some variables, declares a deployment, apps v1, deployment. And I know this is all very pedantic and there's a lot of verbosity, but if I want to know what's in this spec, I don't have to ask ChatGPT. I can just look at what's going on and I get everything from Go Please or from any coding environment that's modern today. So from here, I can do the same thing. I'm just going to reopen my terminal. And I'll just remove what we did before. Not may do, may day, foo. This should remove the previous example. And so we're going to do the same thing. We can go OS, WASI preview one. I've learned that apparently canonically this is called goose and gorch. So if I say that, that's okay. Static.wasm, and we're going to do this flight basic 02, and we're going to build this one out. And so if we run this again, we get yoke takeoff. We'll call it foo again, and we'll use the static.wasm. And this will evaluate to the same thing. And we have the same example come back, except this time we used types and code, and this could be expanded. If you want to change something, we could go in, change the deployments to 3, recompile, and reapply. And this is valid, right? We're going to see the third one come up. Super valid, but not super easy to configure. So if we want, we have a third example of this one, which is just a little bit more involved, but basically the same thing. It's the same imports, the same main run function, except that now we have values in code, a value structure. And what we do is when we run, we declare our values with some defaults, and then we decode standard into those values, and then we can create a deployment, create a service, pass those values through, and we have those definitions, and so we get the same thing. So if we do this again, and open this, and this time we'll do go or goose, WASI preview 1, gorch wasm, go build dash out. This will be configurable.wasm, and we'll put out the basic 3 configurable. Okay, we have this. Now we can say yoke takeoff bar. I'll use a different, I'll say bar and conf.wasm. And now we have 2 bars. This is, I know, is because I'm using the release name to be the same as the flight release name, which I wasn't doing before. So it's okay. So we have 2 bars. And now if I want to configure it, I can pass a file, replicas 5, and go EOF and send that through. And we will have 5 replicas, right? So it just works. But we're not just yeeting text anymore. If I say that I want 2 replicas in English, we're parsing it, right? It's not the same as before. And so that's cool. So that's really the basic CLI example. I have one last one before we move on, which is that we're running arbitrary code, right, that we're compiling to WASM. And Helm is just arbitrary code as well. So if I look over here and open the file system, I can have a program here called main. And next to it, I have a folder called Redis. And in this Redis folder, I have a Redis chart. It's the values.yaml, it's the chart.yaml. We have all the templates from it. It's just basically a Bitnami Redis chart. I can embed this Redis chart. I can run it. We can load it because it's code. We can render it out, pass it the release and namespace and any values that we want, and encode the resources back out because a flight is just a function. And Helm is essentially also just a function. So if we do the same thing, go OS equals WASI preview 1, gorch, this is the last time I'm going to write this out, so it's okay. I'll call this redis.wasm, pass in the flight Helm 02fs. We'll go back to our terminal. And if I run yoke take off of my cache and call it redis.wasm, it should run Helm, run that Helm chart, and we get Redis. So that's that. That's the Yoke CLI. Okay. I want to go back to here. So that was the first demo. But now that we've done this, which is cool enough, is it even really a good idea? I mean, it's a good enough idea and it's a good foundation, but what we've done is we've created another client-side package management solution. And what does that mean? That means that the client generates resources, which is our package, and that constitutes, our service, our deployment, our ingress, our pod disruption budget, whatever we want. And we're sending that across the API boundary into Kubernetes. And so what Kubernetes knows about is those low-level native resources. But it doesn't know anything about your package. So you cannot talk to Kubernetes and ask it about, does it have your app, or how many of them, or validate what their inputs are, or say who or can or cannot create apps. So can we do anything better? And so we can move to a model where you could say we could have server-side package management, where the client creates some kind of application, it's their package, but as a resource, sends it over the API boundary into Kubernetes, and then Kubernetes on the server side would generate your resources. And at that point, we solve the problems that we had. Kubernetes would know about your application, could validate the structure of your application, and could, apply RBAC to it. It'd be great. And for those of you who are familiar with Kubernetes, they're probably screaming, custom resource definitions and operators. And that is where we're kind of going. For those of you who don't know, we can create custom resource definitions to extend the resources that Kubernetes knows about. Then the user can create custom resources of that type. We could have an operator in the cloud to watch those resources, see change events, and then apply changes. And so we could manage through this system packages on the server side instead of doing Helm installs and stuff like that. So why aren't we doing that? And so if we look at frameworks for building controllers and operators like KubeBuilder, which was first introduced in 2018 and is a code generation framework for CRDs and their controllers, and it's probably the most popular one, why aren't we just deploying packages through KubeBuilder and just building out our packages like that? And I think the proof is in the pudding. People aren't doing it. It's too complicated. We don't want to be working on reconciliation loops, orphan states, cleanups, all that stuff. We just want to say what our state will be for our package. So KubeBuilder gets the X. It doesn't work. At least has other uses, but not for this one. We have other types of tools, right? We have continuous deployment tools like Argo CD, and that gets us like more or less there, right? We have a custom resource definition called the application in Argo CD, if y'all are familiar. And we can have a reference to a chart, and we can put values in there, and we send that application across the API boundary, and the resources get created. But still, we're only halfway there, right? We're still just yeeting values into this thing. Kubernetes doesn't know about it. We still can't RBAC this. Anyone who can create an application can create anything in your cluster if they have write access. So you can't really restrict anything. So I'm really sad, but this Q octopus also gets the red X. So what to do? So Yoke has the air traffic controller as another part of its project. The air traffic controller is the controller, and there's an airway for managing flights. The airway contains a CRD specification and a reference to a flight. When the air traffic controller sees an airway, it creates the corresponding CRD and spawns another flight controller. And in that way, we can create custom resources and their resources afterwards. Oh my God. Thanks, Archie. Yeah, we should get like a podium thing. All right, and so we get resources. Yeah, and so that would kind of solve our issue. And so that's what it does. And so let's see this in action. It's the second demo. We're going to come back to here. I'm just going to clear this so that it's a little bit easier. I'm just going to restart, clear this cluster, and create a new one in the background. And in the meantime, we can go over here, look at this ATC. So for our example, we're going to create a generic package type called backend. There's nothing complicated in the code. We're just going to create a deployment and a service. And so we can look at this backend type, right? We're still in Go, doesn't have to be in Go. But we have this type called backend, and it's a normal custom resource type abstraction in code, right? We have the meta v1 type meta, which is your API version and your kind. We have our object metadata, name, namespace, all that stuff. And we have our own specification called our backend spec. And our backend spec is super similar to that example that we had previously with image, replicas, labels, whatever. And this could be your specification. Oh, I hope that y'all followed along a little bit. We can then implement what our backend would be, right, as a package. And so this is almost exactly the same as that previous package that we had seen, right? We had still are importing the core types, but we're also importing this backend v1 type. We still have the same main function. And the difference is that we are now declaring a v1 backend. We're decoding standard in into the backend, configuring some same defaults, right? And then we're using that backend to generate our deployment and generate our service. And if this was a real example, we would have ingresses and different types of resources. And that is the implementation of our backend. So we now have a CRD type. We have an implementation for that as a package. And all that's left now is to declare the airway. So if we see this airway, well, I'm just gonna make this bigger. Right, we are using the v1 alpha 1 airway type from the Yoke project. And we're just basically declaring a custom resource definition. We have a name for it, backendsexamples.com. We're binding it to a URL where the flight is hosted. In this case, in the examples repository on GitHub, there is a release called latest with that flight that we just saw, that program that turned a backend into its resources. We have the API extensions package to create the custom resource definition. And we can just create the group, the names, the scope, and the version, v1, served, storage. And we have the open API schema generated from that type. If we want to look at what this looks like, right, if we were to run, go run this.atc backend airway, and pipe that to YQ, we see that we're generating that airway with its version and with its open API schema based off of the type that we had. So now we're ready to kind of put it all together. So I'm just going to move this to the side. Going to start a terminal over here, K9s. Oh, sometimes it does that. Okay. Let's do this. Vertical terminal, go back to K9s. Here I have a script to make my life a little bit easier. I don't know why I went there. Okay. This is just part of it, I suppose. Okay, so vertical split again, terminal, K9s. Okay, we're in business. Okay, so here we're going to install the ATC. We're going to install the controller. It's the Yoke project, so we're going to use Yoke to install it. We can do a takeoff, create a namespace called ATC. The release name is going to be called ATC, and we're going to use the flight which installs the ATC. So we're going to yank this. We're going to put it over here, and we're going to execute that. And what we can see is that it compiled the WASM. It's executing the WASM module. This one's a bit long because there's a bit of cryptography involved. We've created the ATC namespace. It's still running. We've generated the controller. If we look at its logs, we can see that it is now watching for resources, the components of the controller, and we're watching for airways. We can now, with the kubectl, we can find airways as part of our API. We can now install one, which is that one that we saw earlier for backends. create that. It's going to see the airway and start watching for it. We've created a flight controller, and now we can just create airways. So, sorry for this. If we go to the default namespace, if we just grab this, now we can see that we've extended Kubernetes with our package implementation and with that type. We can just apply this new version of this file, examples.com v1 backend. We're going to call it nginx, and we're going to run the nginx latest image. If we send that over the wire, boom, now we have nginx. We've extended Kubernetes to have our own native packages on the server side called backends, backed by our flight implementation. Yeah. Sorry if that's a lot of in the terminal hacking away. But what's great about this is that this isn't just like Helm or Argo where everything fails afterwards, right? If we try to implement it with 2, this is Kubernetes that is telling us that it's wrong and it won't admit the thing. It's not going to create it in the server, then try to expand it and then break, right? We're now at admission time, right? We get admission validation, we get types that are backable, we get fully server-side package management implemented. So that's the demo for the controller. Sorry for this. In conclusion, what I'm trying to say is that software evolves quickly, and so does the languages and tools that we use, and our practices, thank you so much, should ever be evolving. And that code-first tools afford us greater flexibility, power, and reliability. And it often allows us to shift left and catch problems before they get into production. So package management in Kubernetes has been relatively stable, but there's still a lot of room to innovate. So I hope you guys give code-first approaches like Yoke and the air traffic controller a try. And that's it. Thank you. The project can be found here, Yoke CD Yoke. The docs are here, examples are here, and you can find me on Gopher Slack at DavidMDM. This QR code leads to the project, and I can take questions. I think I speed run that. I don't know.
So I was blown away because like this looks like the whole company behind this, and this is a project that he built, and like worth to probably get into CNCF.
Yeah, I'm trying to get it into the CNCF sandbox and onto the landscape. Yeah, but I had an advantage though. You know that meme where programmers are really, they takes a week to change a button's color during the day, but at night they can create a new framework. Well, my daughter was born in October, and so I didn't sleep at night, and so I built this.
No, I mean it's really amazing, but like, do you have like you already applied and is in the process? Is it how the whole process worked for you? Like, is it?
Well, so far it's been generally good. I put it an application for the sandbox. They asked for me to get more adoption and then to reapply on the sandbox. So far, which is fine. It's supposed to be for experiments, and but apparently you need experiments with adoption. So that's kind of what I'm doing and why I proposed the project for this talk.
Yeah. Sure. Yeah.
Just a few
Yeah.
questions. So we could see during your demo that you were downloading a WASM package of basically resources, right? Helm resources, KSQ resources as well. Do you think that you would eventually need to have some kind of repository interface? Like, for example, I know Helm, they have something, it's basically just an index.yaml, right? Where they reference all the different versions of different packages. I mean, some kind of a repository, like, I mean, I'm used to Maven repository, Go modules, Node.js and so on. Do you intend to have such a repository of useful WASM compiled resources that can be reusable?
Yeah, so it's interesting, right? Because on some level, it's just code. So if you want to make a package, you can just make the code in whatever ecosystem it is, and then just share it, right, on NPM, Go modules, what have you, and then somebody can just pull that code in, build it, compile it, and use it. When it comes to publishing executables, right, like actual charts in that way, you can just basically host it anywhere. And for registries, last week I added OCI support. So you can basically publish your WASM files to container registries. And so people, if they want to produce flights that are WASM executables and share them, you can version them in any container registry like Google Artifact Registry or Docker Hub or anything like that. And so you can share it that way as well. Does that answer the question, or am I?
Yes, yeah, definitely. Yeah, that's it. Thank you.
So he actually mentioned earlier the KRO project that's going on. Obviously, I'm not familiar with Yoke. I'd have to play with it, but it seems like the air traffic controller, that kind of part is functioning very similarly to what KRO is doing. Have you played with the other one?
I haven't played with KRO. I've been talking a lot with, I'm going to do some name dropping. I've been talking a lot with Victor Farsik, which is the DevOps toolkit, one of the advocates for Crossplane. And yeah, it's basically, there's Crossplane, Crow, and this, and they're the three products that are doing this kind of thing, which is just about extending your server side to to have new resources and do package management. I think that Crow just has another kind of YAML interface. And then they have tons of problems around they need to have conditionals and do all these things. And the first 5-10 minutes of my slide was me trying to give my background and say why I think that's not always the best idea. Historically, that's where we're at, and hopefully that can change. Yeah.
So in your demo, you installed ATC with Yoke. Are you confirming that in the age-old chicken and egg problem, the egg came first?
Yes. I think so. Okay.
We talked about how we can use a registry to share code or flights. How do you compose, like, reuse existing resources and build up, like, compose the resources out of them?
Right. So for me, for example, the ATC installer, I could show this, but I'm not going to reconnect. The ATC installer is a main package, right? So it can be just compiled to WASM, but the ATC installer's implementation is in a sub package, which is a Go module, right? Not a Go module, but just like a package in a larger Go module. And so anybody can just go get the runtime for it and compile it. And so I think that the best way to do it is if you have two modules that you want to use, right? Something that creates really great deployments or whatever really is nice and configurable. And then you have somebody else that does another concern and you want to merge those two concerns. The best way would be to import both of those code things, right? At the WASM level, if it's a binary, two binaries, you'd have to call WASM from WASM, which is possible, but I haven't tried and I don't know if I want to try. I hope that makes sense. It's more at the code level. The WASM executable is like the last thing, right? It's like when you call, when you have like umbrella charts or charts with other dependencies, they embed the other charts, right? So in the code world, it's just importing more code, which I think makes a lot of sense, right? Yeah.
Yes. First of all, I just want to say this is very cool, I think. Before I ask my question, I just want to make sure what I'm saying. If I understand correctly, when you deploy on the server, you can also query the Kubernetes API to decide how you deploy your things. Did I understand this right?
Yeah, so in the thing, I created backends. Oh, I didn't do my demo super well. I was speedrunning it. Yeah, when I created that backend, that Nginx backend through the server side, what I did is I created that custom resource called examples.com v1 backend. And then on the server side, the air traffic controllers saw that, computed, they already had the reference to the flight module. It was already pre-compiled and cached. And so it just executed it, found the resources, and applied it with using the Yoke internals. And so the backend that you saw is now part of the Kubernetes API, right? So you can say kubectl get backends. And so if you were running an organization and you have like one chart that you use for your organization and you reuse it 100 times, or you have a chart for your backends and a chart for your gateways and a chart for your front ends or whatever, those could all become native in the Yoke world and in the air traffic controller. They could all be native parts of your Kubernetes API. And so you could say kubectl get front ends, get gateways.
What I meant is in the code that is deployed on the server,
Yeah.
you can query the Kubernetes API to change what you're rendering as resources.
Like if the WASM can call into the Kubernetes API?
Yes, exactly.
Well, the flight itself, right? Are you talking at the flight level?
Yeah.
Yeah, okay, no, so the flights can't do that. So they are WASM modules. And as WASM modules, they cannot, they're incredibly sandboxed. So they can't open new sockets. They can't do any of that kind of stuff. There is a feature for you to be able to read other resources in the cluster. But how that works is like it calls back into the host program. It doesn't do it itself. And the only thing that the host makes available to the WASM module is the ability to look up other resources in the same package. And this is useful for churn and like other things when you're deploying and there's secrets that you want to reuse and things like that. Does that answer your question?
Yes. Just to tell you where I was going with this.
Yeah, go ahead.
Because that was my idea, is if you were able to watch other resources, and if there was, I was curious if there was a way to build like a control loop in a sense, or you depend on the other resources and you can update your resources that you created if something around it changed. I'm not sure if I'm clear, because it's it's a bit of a weird idea, but
yeah, I think it doesn't allow you to write arbitrary controller logic. What it does is that now your backend resource type is a type in the cluster, and now if say you wanted to update it, so you want like a new label or a new replica count, or you want to update the image, you would update it directly on your backend resource type, and then it would get redeployed immediately, right? So it's not really about running arbitrary WASM that implements arbitrary resource loops, reconciliation loops, though that logic that you see that makes resources is basically the reconciliation loop that's run every time a new resource is created. That's like a word salad, but yeah.
Yeah, and I just thought of another question. I'm done with after this one. How is the update of, let's say you change the WASM module and you want to update existing resources with this new version? How does that look?
Yeah, so you can find all of this information in the documentation, first of all. But how it works is there's two levels. There's at the airway level. So if you update the URL, say that you're using an OCI URL to an artifact registry, you could change the tag, and then it's going to reapply it to all of the resources that correspond to that airway and custom resource definition. Or on the specific resource, there is an annotation that you can use to try a development URL. So to say, for this specific resource, use this other one. And then there's also for breaking changes to your API. So you're making a backend V1 and now you want a backend V2. You can create, the ATC automatically supports the creation of conversion webhooks. So if you just provide another type of WASM module that implements the conversion webhook, you can automatically translate between different versions. But I don't know if that's what you were going for or something else, but yeah. So there are those mechanisms. Yeah, so there's automatic conversion webhook support, if you want.
The final question. Do you use any third-party vendor tool to secure your code, what you're running, or you're planning to have one in future?
If I have third-party code in the
security tool to secure. Okay, security tool to secure your code.
Well, it's a pre-version 1 project looking for contributors and trying to mature. So there is nothing running on my code. You can look at my Go mod and the versions and maybe use a Go vet, or not vet, but the one that looks for security vulnerabilities, a Go vuln check, I think is what it's called. But there's nothing really specific. I'm not using Sneak or maybe for compliance, I should start looking
Actually,
into that.
for Sandbox, you don't really need to do, but once it's in Sandbox and you want to go to incubation, there is a process to do security validation from CNCF.
Yeah.
So there's a special organization in CNCF that handles that. But I just want to like get the feedback. Does anybody like see this project that you would be interested to use? Like raise hands. Like this is, you are like, are you platform engineers or what type of role you like? Yeah. So there is a feedback. I mean, like we want to help. This is potentially a future CNCF project, and we need maybe support. So if you want to connect, where we can find you, like Slack or how to work with you.
Yeah. So on the last slide, that's no longer there. It's the David MDM on Gopher Slack. That's where you can
Which Slack?
Gopher Slack.
Gopher? Okay.
Gopher
You
Slack.
need to join CNCF.
I'm also on CNCF, and I think it's also David MDM, but I look at Gopher Slack a lot more. So you can find me in the WebAssembly channels, the WAS0 channels, and just in the direct messages also. So you can slide into my DMs. That's okay.
Do you want to recommend any use case, like specifically where it's like really shines, or I don't know, where would we?
Yes. If you're lucky enough to have something that's greenfield, and you have to write, or not even greenfield, if you have to write charts and new charts and you don't want to do that and you find it annoying and because you can't write tests, you don't have great support, Helm LS is kind of kind of works, but not always. Then you could just write your package implementation in code, right? When we were looking at those case studies of Terraform, GitHub Actions, and Helm, my point there was that we're just essentially programming, but we're not giving ourselves the tools. And we didn't have the systems like Yoke or other future projects to give us those tools. And one of the really big difficulties getting here is that code is kind of volatile, right? It's arbitrary execution. It's not always super safe. And it's like, how do you package code? But with the Yoke project and with the answer, it's WebAssembly. And that kind of gives us a package format and all this. So now we can actually start leveraging code to build our packages. And so if you're writing Helm charts, use this. And if you want, obviously, and if you don't want like a client-side workflow, use the air traffic controller. And I'll just say the air traffic controller works really great with something like Argo CD, because then you can just commit those custom resources that you've implemented into some Git repo, and they'll be created server-side. Argo will pick them up, create them, and the air traffic controller will expand them, right? So there's really a lot of great workflows you can create with this.
Awesome. So I don't want to be between pizza and talk, but thanks a lot, David. And we hope we're going to get accepted to Sandbox. Please, yeah. Please connect with David, maybe at the break, if you want to share the feedback, or if you have ideas, or you think it's a bad idea at all. Like,
yeah,
just be honest, because like we need to help to move this forward.
Yeah,
in some way.
A lot of people are allergic to the idea of code and think that we always just need a better configuration
Love
language.
YAML more.
So if that's your point of view, that's okay too. But if you're not, please star the project. I would appreciate it, as it is how they want me to enter the sandbox. So thank you.
Thanks. So we go for like 30 minutes networking break, pizza and sandwiches from, I forgot the name. What's the company? Who is sponsoring the, yeah, but we have like at the end, there's a veggie version of the sandwiches. So if you're vegetarian, please use the last box. The bathrooms are over there. And then the drinks, soft drinks on the side of. So the place is called Dispensa. It's a nice Italian shop. I go there to have a coffee sometimes, and this is our suppliers now officially. So we have another talk actually about platform engineering. So because platform engineering is so hot, everybody, all the DevOps, SRE suddenly change their LinkedIn profiles, and overnight they become platform engineers. So, and those who didn't change it, they want to change it. So like they're trying to learn what's happening in this world. But I think it's still something in a building, right? We don't have like a defined story. What's the like defined architecture? What's the building blocks? And I think like projects like Yoke could be some of the parts of the puzzle in one day. But I think everybody's still building their own bespoke systems. Sometimes putting like backstage, like, oh, I have a backstage. I'm a platform engineer. But in reality is, it's a bit different. And so it's interesting to see like how different people build it. And sometimes you can learn something from it, or you can maybe help the company saying, oh, actually, guys, there's a better way of doing it. So we're glad that people sharing this, and super excited to have Saeedeh.
Hello.
Can you?
Hello. Oh, okay. Can you hear me? Hopefully. Okay. Hey, everyone. I'm Saeedeh, and today I want to talk about platform for rapid service deployment. I want to tell you a story that we had in our team and how we solve it. And okay, let me clean this quickly. So, okay. Okay, let's start. How it works. Okay. Okay, cool. So let me give you some background of what issue we were faced and how the story starts. So we had some services on premises, and we wanted to move them to cloud. So we chose AWS as a cloud infrastructure, and we started to build upon that. So for example, adding services, authentication, authorization, SSO, everything, and how to do the data management, who should have access to S3 buckets. And so because I'm working for Genentech, it is a biotech company. Data is our main, I don't know. It is very important, so we should take care of it, and we should take care of data management. And then on the top of that, security auditing, and then we brought up some EKS clusters. And then we were ready for having our users on our EKS clusters. But the story starts from here because we faced some challenges. One of the challenge that we faced, and it was the main thing I want to talk about it here, was cognitive load. I don't know if you are familiar with this term, but cognitive load means that the amount of effort required to understand or complete a task. So what does it mean? It means that, so for example, from the start, when you want to do something and you don't have any idea about it, how much time it takes for you to do that task. So in our case, our users that we are talking about right now were data scientists and data engineers. So they had no clue what is Kubernetes, what is deployment, what is service in Kubernetes, and so it was so hard to move their application to Kubernetes because there were some different terminology. There were some different focuses. They wanted to focus on their stuff. We wanted to focus on our Kubernetes stuff. And staffing constraints. So we were a small infra team. We couldn't assign we couldn't assign DevOps engineer to each project because we were short on staff. And we understood that we have some manual workloads. So for example, when we wanted to have application on our Kubernetes, we needed to fix, I don't know, some accesses, some IAM roles. As I mentioned, okay, how to access the S3 buckets and so these stuff were manual. So we ask ourselves that what is our users? Who is our users? So it wasn't an external user. There were internal users, and at that time they didn't care about what is the uptime of our Kubernetes. They wanted to just be able to easily onboard their application to Kubernetes. Okay, so we decided to solve this problem by having a great process and something that's easy to follow for our data scientists. And we wanted to have automatic procedure. And for the fourth one source of truth. So we wanted our users be able to easily follow the process and everything be handled in the background. And just in one file, they can just have their application in the Kubernetes. So the answer actually it's super cool and easy. The solution was one Helm chart to rule them all. So we created a Helm chart and we added all of those if, else, how to do it, I don't know, what the defaults and so inside the Helm chart. And we made the Helm values super easy and understandable for our users. And we use their own terminology. So for example, instead of going ahead and say that, okay, the deployment, what is the deployment image? We use containers, for example. Or for example, instead of going and say that, okay, what is the ingress? We called it endpoint because endpoint made more sense to them. And we had so many default options. Oh my God. Okay, we had so many default options. So for example, here I'm just mentioning that we had a GPU enabled false because in most cases there were model inferencing and users needed GPU. So if they're just enabled the GPU, it will handle everything underneath, all of those taint and toleration and assign resources. So, okay, so we answered how to make the process easy to follow and one source of truth with the Helm chart and easily to understand Helm values. But how about the automation? So we wanted anything about the application be handled inside the Helm chart, be part of the Helm chart. I don't know, the endpoint ingress authentication, SSL certs, access to other resources. So here I'm talking about AWS resources, horizontal, pod, autoscaler, and so more. So we went for easy answer, Kubernetes controllers. So we started to use and take advantage of Kubernetes controllers that were out there, like ACK, which is stand for AWS controller for Kubernetes. I don't know if you're familiar with this controller or not, but there is a super cool open source project that is called ACK. So they just make it easier to access from Kubernetes to AWS services from inside the Kubernetes. So we use IAM ACK controller to just manage the IAM role and assign it to the service account of the application. We use ACM ACK controller to request and handle SSL and TLS certificates. For some of some parts that we were facing issues, we create custom controls ourselves on top of the shell operator. I don't know if you use shell operator or not. It is open source as well. So for example, here we wanted to have our authentication on top of our ingress based on OIDC. And we made it happen by the Okta controller. And other controls like, for example, external DNS controller that was for managing the DNS records in AWS. So for example, on the values that I showed you, you can see that here on the secrets, for example, external secret operator was handling that. On the service account, IAM ACK controller was handling this part. And for the endpoint, Okta controller for the authentication, ACM ACK controller for the certificate, and the external DNS controller were handling these parts for having the ingress be accessible to our users. So, okay, let me go back here. So we answered so we came up with a solution which is easy to follow, one source of truth and resource automation is happening inside that. And we and we treated this Helm chart as a code. So whenever we made some changes in it, we just bumped a version, and users need to, if they want to use that feature, they need to use that version. So here is the abstract of architecture that we were having. I just had two examples here, Octa controller and ACM controller. So on the left, you can see that users are applying their Helm chart and the YAML file to the repository. Argo CD will fetch that and will deploy it inside the Kubernetes. And if, for example, there is a role, ACK IAM controller will fetch that, will create a role for it, and then service account and pod can assume it, and for example, get access to resources. So for example, here pod. And at the same time, whenever there is a new ingress has been created, Octa controller will fetch that, talk to Octa, create a new application, get client ID and client secret, save it to the secret, and then that endpoint, that ingress can be accessed with authentication on top of it for users. So that was a very straightforward thing, maybe to sound, but it was super cool to put together all of the things that is out there together and make it happen. So yeah, that was all. Thank you.
So we have our next speakers coming to set it up just to make sure we're running on time. But we have questions.
Oh, well. All right, just a quick question. What was the impact of this change?
Sorry?
Like what happened to your team afterwards? Like the developers that weren't familiar with Kubernetes, is this actually working? This seems great, but
yeah, it is working. So yeah, it is working. And but I mean that so all of the thing has been automated, so we don't need to focus on it as an infra team. And other teams can be easily just, for example, I don't know, instead of having meetings back to back, okay, how to change your code, and so they can just easily use that Helm chart and make their application move to Kubernetes. Yeah.
Do you release the code to manage that, or
Sorry?
is it? Do you release the code of the Helm chart interpretation? Like, is it public code? Is it open source, or can we use it ourselves?
So right now we are using it in our company, in our team. It is not yet open source, but we are trying to make it cleaner and make it, for example, some part of it like Octa controller or so, having it as open source as well. Yeah. Thank you.
All right. Thank you, Saeed. It was amazing. Yeah, so we have actually now switching from platform engineering into the more exciting world, or for some people not exciting, is Gen AI and AI ML, and that depends. But this gentleman was able to combine AI ML and Kubernetes together, so it's a pretty interesting topic.
Excellent. Thank you for your introduction. My name is Amirreza. I'm a DevOps specialist, currently working for Vineo consultancy company, and we are currently working on Desjardins platform ops services. So this project is actually it's just my personal projects. It's something that I've started early because I wanted to get into more of a machine learning, AI engineering, and long language models. Before getting started, I would like to ask you, who is familiar with RAG? Could you please just lift your hands if you know about RAG a little bit? Okay, that's good. And how many of you guys use LLMs as your daily basis, on your daily basis? Okay, I see quite a lot of people are using it. I think last year when I asked the same question, it was fewer people, but this year is more people. And I very well understand that most of the audience in this room are platform engineers, are mostly focused on DevOps and things like that. So that I'm trying to mix up the machine learning world, AI world with the Kubernetes, and basically how to run some of those things on Kubernetes natively. So the project itself called KubeRAG. And so the RAG, it really stands for Retrieval Augmented Generation. So what does that mean? In a very simple analogy, as actually we're supposed to be a joke, let's say a teacher asks the students, what did the dinosaur eat? And then so student only has certain knowledge about the subject and did not study beforehand. So he only has what he has watched or something. And while the teacher says, well, the student says, well, the dinosaurs were vegan because, so basically what does that mean is just, it's just wants to point out the couple of disadvantages of LLM, which is hallucinations, which is lack of data. In this case, our student, our LLM, it does not have enough knowledge to be able to respond to that question, but it has certain knowledge, so it can make a judgment, but it's not correct. So it's doing a hallucination and is making a mistake. So long language models in their basic form, they only been trained on a certain data and they might not be able to respond to specific questions. So if your company has let's say 1,000 documents, or if you want to be able to respond of those documents or those private data, you are currently not able to do that. So there are two issues with the LLMs at the moment. They are not context aware, and then there is no access to the private corporate data. So these projects were really meant to accelerate the enterprise trying to use LLMs. So, and mostly for the companies that are using Kubernetes. Because you can possibly run all these services separately on Google Cloud or any other environment. But it's interesting to see, okay, how can we actually implement it on Kubernetes, where I can run it on edge devices, I can run it anywhere, basically. Yeah, so some of the examples of the RAG, and I'm a little quick about it, is if you have a legal, let's say a company has a lot of legal documents, financial documents, and they want to be able to use long language models to respond to those financial questions. So that's one of the use cases. Other use cases is enhanced customer support. So RAG kind of empowers the chatbots to be able to respond to those specific questions for the company. We actually built one production solution called Tax Info. It's a free solution for your personal tax questions. And what we did, we basically took all the public tax documents that the governments of Canada provide on their website, and we ingested it into Kubernetes, and then we are responding the responses with LLMs. So that's using KubeRAG, which I will get into in a bit. And then so this chatbot, this OpenAI chatbot that was previously was not able to respond to any specific tax questions because we feed it a lot of documents about taxes. Now it's able to respond to a specific advanced tax questions. So I can ask many different queries. So for example, I prepared a list of questions that I can ask. So for example, something like this, and it should be able to respond to me. Hopefully, if this demo goes right, hopefully this should be able to respond to me. Oh, well, it did not work. So we'll try another query. Yeah, sure. Yeah, perfect. Excellent. Thank you. Yeah, so I'm going to choose another query, just an example, but I don't want to get into too much of a, yeah, absolutely. Oh, shit. Sorry. Oh, okay. I'll see. Oh. Yeah, I think it's the UI problem. Yeah. Oh, no, it doesn't work. We'll see. I can make it smaller. Okay, so basically I sent a prompt, and the prompt was, can you explain formula for calculating foreign tax limits? And so it was able to accurately respond that. And this is all based on the public data. Okay, so this is a production solution. So I'm going to get into how this actually solution works on Kubernetes and how we're actually going to be able to implement it and scale it via the framework that I'm working on, which is an open source project. All right. So in a simple word, in a RAG architecture, all you need is mostly a vector database where you're able to ingest all your data. And then in this case, a person asks a question. In this case, orchestrator, which is responsible for managing the information between the person who asks the questions, retrieving the data. So first it retrieves the most relevant data based on what you searched. And then what it does, it feeds it into the LLMs, into the OpenAI models or any other models in that case. And then based on the context I was able to retrieve from the data that we ingested it, now the LLM has an understanding of what the data is. And now it's able to analyze the data that was fitted in and come up with a new response. And that's why I call retriever augmented generation, because first it goes into a database, it retrieves the most relevant information, and then it feeds it in order to augment and create a new response. So that's really a basic what the RAG architecture looks like. And then so whenever we try to actually implement such a solution on VMs, and it was a lot of challenges in terms of scaling it, in terms of thinking all the aspects about the security, about the storage, about the API design. And that's where the Kubernetes becomes a very good candidate for running such a solutions, because out of box, it already provides you with all those things on the left side. So all the scalable ingestion pipeline, you can build it. You can run a vector database on a Kubernetes. You can have dynamic resources. So there's a lot of things that Kubernetes provide to us that we can use to run these solutions. At the same time, there's a balance where you have to balance it between latency, accuracy, and maintainability and observability. Again, Kubernetes provides all those things for us. And in this case, so we're introducing KubeRAG. So it's a simple Helm chart. It's really to automate deployment of such a solutions. So solutions where you can feed your private company's data and use machine AI to respond and respond to those questions. So just to get a little bit more about the architecture, and please let me know if I'm running out of time or something. And 7 minutes. Okay, I'll be quick about the architecture. So basically, today, if you want to implement a RAG solution, you have different frameworks. You have Llama Index, you have LangGraph, you have many of the different frameworks. You have many different databases you can use for your vector database. You have graph databases that you can use as well. So there's a lot of different combinations that you can put together to build such a solution. And for us, building this project was to not having to focus on building infrastructure for those solutions, but mostly focus on training the data, cleaning the data, focus on the data, rather building an application. So because we know that in all those such applications, there's always going to be a repeatable component that we're gonna have to use. So in this case, what we call it the universal API. So basically, instead of you having to build an API on top of the Llama Index, LangGraph, and AutoGen, we provide a universal API, and you can customize it. You can say, okay, I want to build my solution via Llama Index. I want to build it with AutoGen. I want to build it with LangGraph, and then so once you install this Helm chart, it provides you with the basic things that you need. So it provides you with the ingestion pipeline called data pipeline on top. And so ingestion pipeline is going to be responsible for providing you with an API endpoint. So you can see it provides about 4 API endpoints: upload JSON, upload raw, and a stream. So basically, you can either stream data into that API, you can upload the actual chunk of the data into the API, and what's going to happen is going to be stored in a vector database. In this case, it can either be Fuse, Qdurant, or MongoDB, and we are hoping to expand that. And all those can be run locally on Kubernetes, meaning that you don't have to go to external resources. You can rely on all the local things. And in terms of chatbot, you have universal APIs. We'll call chat, we'll call agent. A chat is going to be a simple, quick question and answers, and an agent is going to be the one who actually is going to be able to run agents. But again, We are not building specific applications for models. You know, we're not specifying it. We're actually making just an abstraction on top of everything so that we don't have to focus on a specific tools and frameworks. Because tomorrow, let's say Llama index might be here, tomorrow it might not be here, so we don't know. So right now, so there's two components to that Helm chart. There's one agent and one data pipeline for ingesting, and agent for being able to respond. And we are hoping to build a UI and a CLI on top of it. It's just a basic one so that you can get started. But right now, this Helm chart is able to integrate with Llama 3, DeepSeek, ChatGPT, and you can even run locally. You can run Kubernetes LLM models locally on your Kubernetes clusters now with the help of Ollama. And actually, there's another project called Cube AI, I think, that allows you to run models locally as well. So that was just a basic architecture. So this is the Helm chart architecture, and so it just consists of a bunch of Kubernetes resources, right? So namespace, ingress, agents, and those things are always going to stay the same, and we can scale it, right? Like pods, we can scale it, all that stuff. So I want to get into a quick demo before I go a little bit deeper. So basically, what I'm going to do, the installation of this Helm chart. It's a simple Helm chart, so it's actually quite easy to install. We provide you with the two basic images, one agent and one data pipeline, but you can possibly swap this agent for your own image. So let's say you want to only use the data ingestion portion, you can get rid of the agent and have your own agent and just use the Docker. So the installation is as simple as doing a Helm install, my release, and the name of the chart, and then my values is where you customize your information. So if I show you an example of the values file that I have, let me zoom in a little bit. Sorry. Yeah. No, there's no coding. So as you can see on top, I'm able to specify what frameworks I want to use, whether I want to use Llama Index, whether I want to use LangGraph, any other things. Then I can define what is my database engine is, whether it's MongoDB, is it K-Durant. And then obviously in this point, I am using the remote Azure. I'm not running any models locally on Kubernetes. So for in this test, I'm using the Azure API. I'm using an Azure endpoint embedding. And I'm specifying what model I'm using. So in this case, I'm using the GPT-4o Mini. And as I mentioned to you, we have a basic agent and we have a basic data pipeline image, but there's nothing stops you from building your own agent or building your own solution and then just replacing that image with your own. So the basics of scaling, it will stay the same, but the logic of your agent can change as well. In this case, yeah, I have a MongoDB database that I'm also using remotely as well. And if you look at a little bit on the bottom here, it says local model false, local embedding to true, and then local Hugging Face model. So those are interesting because if you set the local model to true, then it's going to go and install the Cube AI operator, where it's going to be able to run your model locally, and then it's able to use the local model instead of using the remote model what I'm using on top. You also can specify your Hugging Face model. So if you bring in your own open source model, you can bring it as well. And then in this case, I'm using a local model to be able to embed it. Okay. So just to get into a little bit more interesting demo, that's what I did was for the purpose of this demo, what I did was I did a cluster info dump of all my Kubernetes cluster. So basically, I took an entire JSON file of the cluster that I had. In this case, I extracted it here. And then, so let me actually do an installation live here. So as if you can see, let me just zoom in and zoom out a little bit. Yeah. So if you see my screen here, I'm gonna just change that to, let's say, a demo for this purpose. And as you saw, I'm specifying my values file that I had here. Okay, so I'm gonna install this. Hopefully, this is gonna go well. Oh well, I think something did not go well. I'm just gonna uninstall the current F, okay. Oh. Okay. Okay. So that should install it, and I'm just going to reinstall it again. Thank you for yeah, thank you. Perfect. Yeah. So I'm just going to do a simple installation of this Helm chart. Hopefully it's going to go well. Okay. Yeah. Just gotta have to wait because it's been terminated. Yeah. So while this is installing, what I'm going to do, I'm going to show it to you. So just going back to the demo that I was doing, I did a whole JSON dump of my cluster. So this will include all the information about my cluster, including some logs as well. And then I ingested this into the my database, and I'm going to ask the LLM, can you explain to me some information about my cluster? Can you tell me what are the errors that you see in my cluster? What are the issues and anomalies that you find? So once let me just do the installation here. Hopefully this is going to go well. Perfect. So it's deployed. So while this is deploying, I'm also going to apply a secret. This secret will be one responsible for all the API keys and everything. So I'm going to try to apply this as well. Sorry, just a sec. Should be this one. So let me just apply that file and where it should be. Yeah, perfect. So if I look at my yeah, thank you. So sorry, how much? Yeah, okay. So yeah, if I do a kube get pause.cncf, okay, perfect. Let me see what's the issue is here. Just gonna do the uninstallation again. Sorry. I just need to find the secret. My apology. CF, yes. Oh shit. It's my apology. I just had a one secret that I need to apply. Yes. Yeah. I'll just this. My apology. Okay, perfect. I think this was it. Okay, perfect. All right. So let me just do the installation here again. So I had all these commands ready actually. Okay, I'm just gonna delete it. I'm just gonna continue with the presentation, and then we'll get back to this in a second. Okay, once this is completely deleted. Yeah. So just going back to the presentation. Yeah. So one of the use cases that we are actually trying to use this KubeRAG is for real-time log analysis via LLMs. So as you can see, what's going to happen is in the demo, I'm going to show you that it's going to expose an API endpoint called chat or any other things. And then what we can do, we can use some sort of a log forwarder. So if you have let's say a Fluent Beat or you have Logstash, you can point it to that API endpoint with the TCP protocol, and you can be able to forward your logs to this API endpoint. And based on that, it will actually make, it can actually respond to your log issues. So you can kind of analyze your logs as they're coming in via the LLMs, and then you can also build more advanced AI ops functionality on top of it. So if you want to like learn more about how to build the real-time analysis, log analysis for Kubernetes via this framework, you can also look at the live YouTube channel as well. So just going back again to the demo, hopefully this time is going to work. Perfect. And I'm going to also apply my secret here. Perfect. All right. So let me see.
Demo gods, please.
Okay, perfect. All right, so I
Right.
can see, so I don't know why my data pipeline is not running, but I know that my agents is running. So that's fine. And then I already, by the way, I already ingested this giant JSON file because I know it's going to take 2-3 minutes for the LLM to process that. So we already ingested that file. But what I'm going to do, I'm going to show you, sorry. Yeah, just so as you can see, there's two services that are set up here. So kubectl get SVC, CNCF. Yeah, perfect. So you can see that there's a CNCF agent service and then the CNCF data pipeline service. So I'm still waiting for it to provide me with the public IP. So it's still pending. But once it's provided me with the public IP address, I'm going to use Postman to simply make a query to this API endpoint. Okay. So let me actually find a query that was interesting. So I think I tried this one. How does this? So once my service is up and I have my IP address, I'm gonna ask the question, and I'm going to try to zoom it. Are there any patterns or anomalies in the log data that data was provided? So let me just wait for I'm still waiting for the external IP here. So once that is up, I can use the external IP. Maybe some questions. Yeah. While we are waiting for that, if you have questions, please feel free.
KubeRAG.
This is really cool. Thanks. I had a question. Do you have this code available somewhere?
Yes, absolutely. This is an open source project, by the way. I really forgot to mention this. So this was meant to be an open source project. Yeah, so actually I see that there is an IP address. So yeah, just to answer to your questions, we do have a GitHub repository. I'll share that at the end. So this called KubeRAG project. It's already at the version 004.
Ready for production.
Yeah, for 004. Yeah. No, it's still a lot of work in progress, but yeah, for sure you can access it, you can run it, and then hopefully the getting started should be as simple as you running the helm install command. And yes, we need to also expand on the documentation. As you can see, there's no documentation. All right, so let me just go back to the demo now that I will have the public IP address. Perfect. So I see that IP address for my agent. So I'm going to copy that IP address and I'm going to come here. I'm going to ask a question here. So let me just replace the IP address. So hopefully this should work.
Woo!
Perfect. Yeah, so what it did was basically I ingested my log data into the database. Then I asked the LLM, are there any patterns or anomalies in the log data that was provided? As you can see, it was actually very well able to analyze it. It's saying, let me just make it bigger. It's saying the log data shows consistent TCP connections from the IP address, blah, 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 to the server with the series of successful responses. So it does do the actual analysis and there are repeated entries for the same request. So if there's any anomalies, you actually can detect it. So I thought that was really a cool kind of a mix of LLMs with the long language models and the Kubernetes. Yeah, go ahead, please. No problem.
Thank you for the live demo. There's not many courageous people like that who can go on stage and demo it. Thank you.
Yeah, sorry, one more question for this log analysis. How you would organize it? Because it's a continuous flow of the logs, right? Would you check it time to time, like every minute, every 5 minutes, how you would analyze these portions of the log?
Yeah, so these APIs are all asynchronous, so you can call them on an asynchronous basis. But if you're ever planning to mix that with your log analysis, then you need some sort of a queue system. So you need to you either queue your logs, or in this case, what we're doing with the Fluent Beat, for example, we are doing it in a batch basis. So we are sending the logs on a batch basis and we are analyzing them on the.
What I was thinking is like, is there kind of solution where you start it, it is sitting there analyzing everything, and if something, it just send you some notification?
Yes, absolutely. So this is actually a product we are working on. It calls as, I don't want it to be a marketing kind of thing. It calls Sraf Guardian. This product is actually meant to be a full end-to-end AOps product. So we are still working on it, but it's something that is coming up. So if you ever follow me on LinkedIn, you'll see that project coming up. But it's the basics of it's coming from the basics of that. So if you ever wanted to kind of, yeah, I'll show you, I'll give you the information about the whole thing, problem. Yeah.
Awesome, Amir. Thanks for sharing the project.
Yeah.
Are you gonna donate it to CNCF? Planning to donate, or?
Yeah, maybe, hopefully, if everybody's likes this kind of projects. And I believe the best way to run these LLM applications is on Kubernetes, because it allows you to mix it with your private data and everything. So Kubernetes is an ideal, I think, platform.
Maybe anybody else knows other projects that are similar, or like it's unique in your opinion? Maybe, I don't know. Did you see any other projects yourself? Or
no,
the reason because you didn't see it, you built it.
Exactly. Because what we did, we had to redo everything. Every time we wanted to implement a RAG solution, we had to again and again build the same thing. So we just built a framework.
It could be good for, let's say, using it on edge IoT type of devices where like cloud is not available. It could be
Exactly.
interesting solution.
Yeah, exactly. RAG for edge. So that's something that we are also thinking about it.
Yeah. Cool. Amazing. Thank you so much.
Appreciate it. Thank you.
Thank you.
So Marat is our senior speaker. Likes to present a lot, and he's part of Sysdig. But today we're gonna continue about discussion about LLMs, large language models. But in this case, we're gonna put it in the context of container runtime security with Flaco.
So thanks, Archie, and thanks everyone for staying so long. The last man standing, because it's always like not many people at the end of the talks, right? And I really appreciate that everyone stayed. Anyways, why I was asking a lot of these questions, I was thinking about the similar problem, but in angle of cybersecurity, pretty much. And during today's talk, I will be talking about how you can use Flaco and some LLMs to help you with cybersecurity, basically. And a bit of about myself. I'm Marat, and here is that QR code. You can connect with me on LinkedIn while I'm talking. So I worked in IT about 20 years now, did a lot of different things, servers, administration, I don't know, storages, Kubernetes, DevOps. And now I'm doing more security in cloud and containers. And I love Kubernetes, and here is why, you can see. So you probably saw that car, one of those outside also.
He stole all the numbers.
I'm so crazy. You can see how crazy I am, you know. Anyways, so what is Flaco? I'm not sure if anyone aware about knows Flaco. Not many hands. So basically, yeah, Flaco is a CNCF product for container security, we call, right?
It's a project. It's not product.
Oh, project. Yeah, sorry.
Not selling.
Yeah, absolutely. Yeah. Project. Sorry. And it is graduated project, and basically it can do container, Linux hosts, cloud security, you call it, and it can be extended by many different plugins. And you can see a lot of downloads and a lot of big stars. Those stars apparently required for getting to CNCF. So, yeah. This one has a lot of them, you know. Anyways, so what is Flaco? Flaco is a security camera for modern apps, we call it. We can install it on Kubernetes clusters. It will hook up to underlying node like kernel, right? And through eBPF or kernel model, it will be detecting different syscalls, and based on those syscalls, it will be basically alerting you if there is like specific combination of those syscalls. It will be alerting you about different security, I don't know, events in your environment. So what is it? Runtime security engine, right? Observability for endpoints built on eBPF. You still can use kernel model integrated with Kubernetes, but not only. So what else it can do? It has a huge list of different plugins. So basically, you can inject different cloud logs, Kubernetes audit data, some Docker events, GitHub. You can integrate it with many different products and basically detect some malicious activity in those products. Now, I want to talk about some other components of the Flaco ecosystem. Flaco Sidekick, it's a component where you can send all the detected events from the agents, right? From the Flaco, the deployed Flaco agents. And Flaco Sidekick will combine everything together and filter through them. And you can use it to forward your events, security events to different receivers. And again, there is a huge receivers list, and you can create your own as well. Another interesting part, if you are thinking about automatic auto response, remediation of the certain malicious activities, right? There is a project called Flaco Talon, and that one is pretty interesting. From Sidekick, you can send notifications to Flaco Talon, and it will. You can write different rules there, and basically based on those rules, you can execute different response actions. If it is Kubernetes, for instance, you can kill the pod. If it is like Kubernetes, again, if you want to isolate, you can create network policy, for instance. You can do all the different things. The same thing with the cloud also. And again, you can use it with all other different auto response engines. So you would think it is open source, maybe it's not used, but here is some of the users and contributors to Flaco project. A lot of different companies are using it. So if you would like to use it, start using it, you're always welcome, and you have huge community behind you. So now the main topic, right? So how we even got to this point, when you see these dashboards of Flaco, for instance, right? You can see here all the different like output, all the different tags, a lot of information, and you can get overwhelmed. And if you are, for example, like part of SOC team, and if you are junior like member of the SOC team, right? You would come to this, you would receive some alert, and you would see, okay, what does all this mean, kind of, That's where we were thinking about how we can integrate AI assistant, the different LLM models here, so that they can help to make sense of all these events and maybe suggest some remediation steps and some other details. So that's how we got to this point, basically, and decided to extend Flaco Sidekick UI with extra Flaco AI Assistant component, basically, which is using OpenAI's AI Assistant API, and with some specific instructions and some extra functions, we can call that API endpoint and make sense of our data. So how it's implemented, here is some resources. Later you will be able to download those from the slide. And how it basically works, we go to the specific event here, right? And our event details here, we integrated some AI assistant button here. As soon as we click that, hopefully in my case, demo would work a bit better. It starts spinning and thinking, basically. And what it does, it posts my event details in JSON format to the AI assistant, and AI assistant basically has certain instruction on my end, I mean on the AI assistant configuration part, and we can set extra instructions from this end. And this one actually using OpenAI's LLM models, and they are dealing pretty well with all the different Falco events, and they work like explain nicely. So in this particular case, we see this drop and execute new binary container event has been triggered, right? And it is XMRig. I guess everyone know what XMRig is. It's a cryptocurrency miner. So we can see priority is critical, right? It's providing different summary here. Unauthorized binary, it says, right? Some another interesting information here. And it was saying also that it is running within basically Nginx container, which is probably really not secure, right? Then we can ask like, okay, I have no idea what this is talking about. I'm super junior. I'm coming and asking like, okay, am I in troubles? And is this dangerous? I'm asking like simple question. It start thinking, you know, like, yeah, not smart, probably question too. Yeah. And it gives me all the answers here. It is saying that it is pretty dangerous. Yeah. And then I'm thinking like, okay, I remember I ran this in my lab, this XMRig, and like maybe it's not so dangerous because it was me running stuff in my lab. And I am asking now my AI assistant, can you please create exception for me, Falco rule exception? I remember I was running this in my lab. Can you please? We always tell please to AI assistants, you know, please create Falco rule exception for me. And I hope it will work because usually it was working. So it will think about this again, and it will provide all the details to you. I mean, in this particular case, you probably wouldn't add any exceptions here, but like, yeah, you can see it provided pretty nicely formatted rule here, but not exceptions. So in this particular case, it didn't work. So again, we can improve all this functionality by using solutions like KubeRAG, where we would add all the different rules and exception examples, you know, and it will train on that, and it will be able to provide more accurate information. In previous runs, surprisingly, it was doing much better job. I guess it got overwhelmed with my requests, but that's pretty much it. And what we were thinking as a next step, we were thinking about to improve all these like different scenarios and different options where we can use this, and also implement some more advanced things like flow of the events that would be basically checked by AI assistant, right, AI agent, and it will be providing all the inputs and insights onto that data. So that's pretty much it. Thanks, everyone.
Ooh, thanks for demo. So questions? Now you are in trouble.
What security notification does Falco or Falco in this case provide above and beyond what's already offered in the Elastic Kubernetes stack? And if you want to do an integration with Falco Talent, does it automatically notify the EKS, or is there some intermediary that you have to build in?
Yeah, that's a very good questions. Yes, Falco Talon has different type of responders, and one of them is Kubernetes. So basically, you can configure it whenever it receives the event related to some specific cluster. If you have all the configurations in place, it will be executing whatever auto response action you will tell to execute, basically.
What I know for a fact, the hardest, I think, part is using Falco is like building those rules, because in a company you don't have like a lot of smart people who knows only Falco, because like we have to know so many things. So I think these tools could be useful to, if let's say I have a junior security specialist, he's like, I'm still learning, and this is can help like to get started, right? Is that the goal?
Yeah, absolutely, yeah.
So just so I'm clear, you're not feeding every event into the LLM, right? You're feeding every event?
No, in
Okay,
this
just when a tripwire goes, then you go to, okay, cool.
Yeah, exactly. In this particular case, it's a really like straightforward, simple scenario where it grabs that JSON payload from the UI directly, and it posts it further. Another option we were thinking about, get the time frame, and we have a events API endpoint, and collect multiple events and send it together and say, okay, can you make sense of and summary of these events? And that's pretty much interesting scenario as well. And yeah, that might be one of the other implementations of this.
All right. You see, those guys can work together in the future. Yeah, the solution.
Yeah, no problem. So you mentioned earlier that you were using OpenAI API. Is there a way to swap this model for another model, or is there some features that you're thinking about in future?
Yeah, absolutely. That's what we were thinking about, to make a more interface, so that we have some pre-configured instructions, right, in the UI, but backend LLM model, you would use a different one, whichever you would prefer. We actually were thinking about using local ones that you can run in your own environment. So if you are basically concerned about your data going out somewhere, it will be just locally running in your own environment.
Makes sense. Thank you.
Gemini. All right. Thank you so much, Marat.
Yeah, thanks everyone.
We just want to make it, keep it short and sweet. I think this is the kind of end of the event. Like we have no more speakers, but we're gonna stay here for some time if you want to chat and connect. The next event, like we're going now, like there's KubeCon and all these things. So we're planning for the next event in Q2, probably May, around this time, and hopefully at Lightspeed. If you want to host in your venue, please let us know. We're always looking. So, but like right now we have a home for CNCF events. We are super happy, and I want to say thank you. We had like about 10 people submitted demos and talks, presentations. So we choose today those 4, but there was few people who also had a very good, interesting talks, but like they were not able to join in specifically today. So, but if you are interested to speak, please reach out to us, to me, to our organizer team. We can help you. We can jump on the call. I was like on the call with the Amir and with all the folks who are getting ready for the talk, because like we are all end users. We cannot maybe bring always speakers from abroad, and we're trying to find a way for you easier to prepare. And sometimes like you can do 5-minute demo, but like there's a big value, and I'm really thankful for all the speakers today. They shared their stories. Sometimes it's intimidating. You can think, oh, it's just like a bunch of bash or a bunch of Helm, but like there's actually some things that sometimes you can discover and share. I think it's important that we're all sharing this information. And so I think that's the value for this. And yeah, that's it. I think if you like this type of talks around LLM, and if you're building something, we also have another event in Montreal, which is called AI Thinkers Montreal. It's a more community for the builders. So if you're really playing with the tools, with the RAG and with the large language models, there's another event also that there's a bunch of events in Montreal, but this one is pretty good, I heard. So yeah, And yeah, we're looking forward to connect with you in May. And thanks everybody for coming. Any questions? All right.